Welcome to Python Labs. In this video, we will discuss how to perform dimensionality reduction using feature selection approach. Just a recap on what is dimensionality reduction, which we have already discussed in one of my previous videos. It is basically identifying the most important features while reducing or removing the least important features, especially if you have a big data set with too many features or columns. Then this is one of the best approaches we need to do, and this is actually in fact part of the pre-processing technique. So in this particular video, I will cover what is how to approach dimensionality reduction using a technique called feature selection. Now what this feature selection does is basically it tries to identify the measurements or the dependencies between two variables. In this particular case, it will try to compare each of the independent variable against the target variable, how much they are dependent to each other, and the most important features. That is how it collects. I will try to explain you in a minute with practicals. Now first things first, the first thing I'm trying to do here is to import certain libraries as usual. So I'm going to make it bigger screen so that it's easy now. So step one, all I did was basically to import the library, which is basically the NumPy, the Matplot and Pandas and Seaborn. Not all of them are useful, but this is basically the most common when it comes to data science. So I just kept it as is. So step 2 and 3 is basically again part of the best practice. Read the data from your whichever source it is. In my case here, it is I'm reading the data from the CSV file, and then I'm basically having looking at an overview using the data frame dot describe. So just to make sure that all the features and what are the basic statistics looks like. So I'm going to run that step 2 and step 3. So basically these are basically my stats with 36 features. I have 36 features here. So next step is basically splitting the features again into dependent, which is my target, and the independent set. So basically I need to, first thing I need to do is to split my data set into dependent and independent variables. Obviously the dependent variable is my target, which is my last column, which is complicated in this particular case. Is the complications, whether the patient is having complications or not, and the rest of the data or the rest of the columns are basically independent. So now what I'm going to do with this particular feature selection is to compare the dependency of, for example, complications against type of operation, complications against perforation, and so on. So like this, basically for all the columns, I will try to perform what is the of significance in terms of each of these dependent and the independent variable relationships. So the code is pretty straightforward there. So all I'm doing here is I'm trying to take into consideration all the features except the last column, which is my complicated cases. So basically that is my independent features, and my dependent is the last feature, which is basically the complicated. So I'll try to run that code again here, and I'm just having x dot head just to see how the data looks like. You can even write x dot tail and whatever you want to write. So the next step you need to do after this step 4 is basically splitting the data into the test set and the training set. So remember, I have already covered this again in my one of my previous videos. We split the data into training set and the test set, so that we basically train our algorithms or whatever the models we are doing with the training set, and then we test against the test set. So test set is something that is like as if it's a new piece of data. So we do not use we don't use this test set as part of training the models. So that is how the general rule of thumb is, to divide it into 80% training and the 20% testing. But it's up to you, if you are depending upon whichever is suitable, 70/30 or whichever is most suitable. So I have used here the sklearn model selection to split the data into x train, x test, y train, and y test. So training set and the test set. So once I split the data here, I can even see how many records are there in each of these training set and the test set with the help of this x underscore train dot shape comma x underscore test dot shape. So if I run this code, for example, if I run here like this one, so it shows me that there are 310 records and 35 columns for the testing, and around 104 records with 35 columns. Again, it is for testing purpose. So this is basically how the best practices. These are basically the standard steps that we need to do. And after this is the most important part for today's video, which is about applying the feature selection. Now, as I told you before that, there are feature selection is one of the ways on how to determine which are more important features and which are less important features. So in this particular case, we have two different options to go with. So there are two ways actually in the sklearn feature selection. One is for discrete variables, which you can basically count or something in groups, or it is a continuous variables. If you continuous values, I mean target variable. So which basically, like, there are two different class algorithms. One is called mutual info classif, that is for discrete. The other one is called mutual info regression, that is for continuous variables. Now the code that I have written here is, first thing is for the this part discrete variable, because I know my values are discrete, most of the values. So I have applied this one, and let me show you how it works. The first things first, first you read the feature selection and import this particular mutual info class. And then what we have done here is we are passing the training set, and actually this is not needed dot fill na, but if you end up having some values which are zeros, then it is always better to put this dot fill na. If there are some empty cells, then just fill it with zeros, and then you are passing the white train. So basically this is how you pass the feature selection. So once you do this one, let me run this code for you. So it will show me, once I do this, like, basically the feature selection using the discrete target variable. Now it is showing me all in an array. In an array, it is showing me each of the variable and what is its dependency on the target class. In other words, how strongly they are dependent to each other. Now this is looking very odd. You see, this is like an array. So what we can do is, we can do the next step, which is basically to see the data along with the column names, Let's try that one. So if I run the same thing again, now I'm basically trying to see the dependency of the independent variables against my target dependent variable. Then I can see here, and I have written basically the code saying that, show me the list in the highest to the lowest order, and all these are basically nothing but my columns. You see there. So the highest dependency, my target class, which is complication cases, is pretty much dependent on the, for example, perforation, followed by the pus formation, followed by the neutrophils, and followed by the symptoms, how many days the symptoms have been occurring, and so on. So it goes on until the values are basically the least important features. So this is basically how easy it is to display the mutual information. That's what we call it. In other words, the dependencies of each of the independent variables. In this way, what we can consider is, we can just consider maybe the top 5, top 10, top 20 features. Now again, let me put these numbers into some kind of graphical format. So that is my next step, which is step 8, to visualize in a graph. So whatever the list I got, and that list I'm basically showing it in the form of a graph here, showing with the highest to the least important features. So if I run this code, you see here, if I run this code, basically run, all it is doing is, it's basically, I'm having a bar graph here, and in this one it is showing me that these are the highest dependent features in my target class. My target here is complications. For the, to determine the complication cases, it is basically saying these are the important features, and continues on. So just by looking at this particular diagram, we can clearly say that, okay, we will just consider the first top 10 or top 5 features, which are the most important features for my target class. So this is how easy it is. Now again, we got the data in the form of a bar graph. So the next step what we can do for that is basically We can view the list, the information in a kind of in a kind of a column wise. For example, let me run this code. I will explain to you. You see here, now it is basically showing me all these are the for example, this particular code what I have written here is, among all these features I'm actually interested in the top k features. Here I have passed the top k features k as 5. So if you just look at this graph, you can see that the top 5 features are perforation, pus, neutrophils, symptom days, post operative length of stay. And if you apply the same thing selecting the k best, you will see that it also gives us the same results. I mean, there are either ways you can manually select and you can start deleting the other columns if you want, or you can pretty much use this kind of logic, which is basically select k best. This is features according to the k highest score. So again, I always try to remind you, and very important that for each of these how the algorithms works, I strongly suggest you to go and have a look at the scikit-learn, because it really explains here. Like for example, this is talking about feature selection, removing all those features whose variance doesn't meet some level of threshold. And also, like as I mentioned to you, that there are two different types. One is mutual info classification, the other one is mutual info regression method. Classification is for estimating mutual information for a discrete target variables, whereas the regression is for continuous target variables. So the one I have shown you is the discrete target variables. Now once I run this code, I have got the list of columns or the features that are the most important. So what I can do, the next step is basically I can run this code. What I am trying to do here is actually to update my training set and my test set with only these columns which are the most important. I'm not worried about the remaining columns. So if I just run here, basically is x underscore train dot location of, I'm taking into consideration all the rows, comma, I'm only interested in those top 5 columns. And the same thing we need to apply separately to the test set as well. Remember, I mentioned to you before as well, don't apply all the whichever the modeling techniques you are doing together for both test and training as one data set. It will lead to information leakage. That's why we should always split the data into test set and the training set, and then we should apply the whatever the changes we are doing separately for both training set and for the test set. So if I'm going to run this code, basically what it is going to do is, it's going to, let me show you this, it is going to basically delete all the columns. I'm not interested. I'm only interested in the 5 the most important features. So these are the 5 the most important features. This is from the training set, and again the same features from the test set. So this is how we can reduce the dimensionality. For example, in this particular case we had like around 30 features. I have considered only the top 5 features. You may consider maybe the top 10 features, and then the remaining features which are not that dependent, then we can simply ignore them. So this is one of the best approaches that we can do as part of dimensionality reduction. Please note that I have also covered one of the in my previous video how you can use the heat maps to identify the correlation and reduce the dimensionality dimensions there as well. So this is another approach, and in this particular approach there is also, as I mentioned to you, that we have basically what we call as this I have already covered, the regression approach. The regression is for those variables which have continuous values. The steps are exactly the same. The steps are exactly the way the same steps that we did from step 6 to 10, except that instead of calling there classification, we are calling here mutual info regression. This is the only difference. If you look at the code, like if I go back to the previous one, you see here step number 6, it is basically we were using mutual info classification there for discrete variables. Now if you have, say for example, you have data with too many continuous variables, then you can use the mutual info what we call mutual info regression. So if you run this code again, I will have to rerun this code because I have deleted the columns. So what I'm going to do for the purpose of this demo, I will try to comment out the code where I am actually deleting the columns. which is this one. So I'm going to hide this, comment out this one. So now if I run this code again, run all, okay, fine. Now what it will do is, it will basically, because I have I'm not deleting, so that's fine. So now step 6 to 10, again we can do the same steps, but this time we are trying to do for the using the regression model, assuming that the values are continuous, and then the same steps again, 6 steps. Number 6, basically finding out the array of the dependencies. Step number 7, listing out the features with the highest to the lowest dependencies. And the next is basically again the same thing. Step number 8, displaying the data in the graph. So this is how, and then after that the step 9 and 10 is basically making changes, like deleting those columns which are least important. This is how you can perform easily how to on dimensionality reduction. I hope you have enjoyed this video. Thank you.